All right, guys, welcome back. We are moving on to homework 8.2, and I'm going to be starting on number 3. So, for this problem, they say in a study of the accuracy of fast food drive-through orders, one restaurant had 31 orders that were not accurate among 353 orders observed. They want us to use a 0.01 significance level to test the claim that the rate of inaccurate orders is equal to 10%. And then, does the accuracy rate appear to be acceptable? So first things first, we're going to make our hypotheses. So it's kind of cheating when I do the problem first, I suppose. But when we're creating our null and alternative hypotheses, we want to look at the problem and decide how we want to compare them. So for this one, obviously we're using a proportion because we're seeing how many orders were inaccurate amongst a total number. And for the last portion, they want us to test the claim that the rate of inaccurate orders is equal to 10%. So whenever we're making hypotheses, we don't typically use percentages, especially since we're talking about probabilities or proportions. So we're going to change this 10% to a decimal, which is how this becomes 0.10 or just 0.1, depending on how you want to think about it. So for our null hypothesis, we are looking if it is equal to our threshold of 0.1, and we're really only interested if it's equal to. So our alternative, if it's not equal to it, it has to be not equal to it, which is just our equal sign with a cross through it. So once we have our hypotheses, we can write out the remainder of our problem. So if we pick out all the things we know, so let's see. We're given our proportion for our sample, so we can actually create our p-hat. Because remember, p-hat is just our number of things observed, whatever we're measuring, over the total. So since we're measuring inaccurate orders, it would be 31 over our total, which was 353. So just over 353. So our p-hat would be equal to 0.0878. And we're looking at our p. We're measuring if it's equal to 10%. So our p would just be 0.10 or 10%. And the equation we're going to be using for this problem is z is equal to p-hat minus p over the square root of p times q over n. So the relationship between p-hat and q-hat is the same as the relationship between p and q. So we don't need q-hat for this particular equation, but we do still need q. So q is always just equal to 1 minus p. So it will be equal to 1 minus 0.1, which is 0.9. So once we do that, we actually have everything that we need to fill in the problem. So our z will be equal to our p-hat, which was 0.0878, minus our p, which was 0.1, or 0.10 if you like thinking about it that way. And that's all over our p times q. So 0.10 times 0.90. I'll just put parentheses for now, divided by n, which was the total number of orders, which was 353. So once you do all of that out, our z-score would be negative 0.76. And then to get our p-value, it's actually going to be, if it was one-tailed, it would just be our area we find in the table. But because it's going to be two-tailed, because we're dealing with an equals and not equals, it's going to be 2 times our area to cover both tails. So if we looked 0.76 up on the negative side of the z-score table, it would give us an area equal to 0.2236. But again, we're going to have to take that number times 2 because we're looking at both tails, not just one, because we're doing a not equals. So our p-value, when we calculate it by hand, would be 0.44, if I was going to round, 7. So you can see when you do it by hand, it is a little different from what I have here, which is 0.446, but pretty darn close. It gets a little different when you're using a table. So next, I'm going to show you how to find this using StatCrunch, as opposed to doing everything out by hand. So if I just clear all of this, we can go to question help and then go down to StatCrunch. Remember, you can always get into StatCrunch if you just click down there. I'm just going to make this a little smaller. All right, so this should look fairly familiar to all of you. So we can actually go to Stat, like we usually do, down to Proportion Stats, since we're dealing with a proportion. We're only dealing with one sample, and we're dealing with a summary of that sample. We don't have data points. So we can click there, and it will ask for a number of successes and our number of observations. So for our number of successes, we're really looking for the number of things we're measuring. Because remember, for this problem, we're actually looking at drive-through mess-ups, which most of us would not call successes, but a success is just what we're measuring. So we had 31 successful observations of inaccurate orders. So for my problem, I had 31 orders that were inaccurate among 353 that were observed. So my number of observations would be 353. And then we want to make sure we change our hypothesis, or I guess our hypotheses, because we're changing both, to match our problem. So we were looking for it to be equal or not equal to 10%. 10. So we just want to make sure we have P equals and the P does not equal, similarly to our hypotheses here. And then once they all match, we can hit compute, and it will give us our z-score and p-value right here for our problem. So that's the alternative to finding them by hand. And then for the last portions, we're going to compare our p-value to our alpha. So they tell us that we have a significance of 0.01. So our p-value was 0.446, and our alpha was 0.01. So our p-value is greater than our alpha, and whenever that happens, we fail to reject our null hypothesis. So remember that if you're unsure of which one to do, remember it's in your cheat sheet. Please use it. And then you can move on from there. All right, guys, so I want to do another sample problem on 8.2 because I know this one is a little bit more on the difficult side. So this problem says, in a recent court case, it was found that during a period of 11 years, 884 people were selected for grand jury duty, and 42% of them were from the same ethnicity. Along the people Among the people eligible for grand jury duty, 78.6% of them were of this same ethnicity. So now we're going to use a 0.01 significance level to test the claim that the selection process is biased against that same ethnicity to sit on the grand jury. So we want to identify the null hypothesis, alternative hypothesis, test statistic, p-value, and then make a conclusion about the null hypothesis and a final conclusion that addresses the claim, which is a lot. So step one, we want to identify our hypotheses. So we want to see if a jury selection group is biased against a certain population. So if we know that 78.6% of them are that ethnicity and people are chosen fairly, then they should show up 78.6% of the time. So 78.6% of them would be our threshold for our probability. And then if we're measuring if they're biased, then we want to measure the probability of getting less than 78.6%. So that's why we choose this as our hypothesis, or I guess our hypotheses. So moving on to the test statistic. We could calculate this by hand, but I wanted to do another example showing you how to use StatCrunch. So the important thing when we're using StatCrunch is when we go there, so I'm going to open it the same way. I'm going to shrink it down again because I don't need mine to be that large. We go to Stat. We're still dealing with proportions. We still only have one sample. We're still dealing with a summary. We don't have a list of data points, but it's going to be asking for a number of successes. So if we look back in the problem, it doesn't actually tell us how many people were selected for grand jury trial that were of that ethnicity that we're measuring. So all we have to do is take the number of people. So we had 884 people, and we can multiply that by the percentage of them that sat on the jury. So they tell us here, the grand jury selected 42% of them. So that would tell us how many people of that ethnicity actually did sit on the grand jury. So if we do 884 times 42%, it would give us 371.28. But if you remember, I always tell you, you can't have just part of a person sitting on the grand jury. That would be both terrifying and inaccurate. So we want to round this up to the next whole number, which is 372. So once we have that, we know our number of observations that we're measuring is the 372 people of that ethnicity. So we can clear that and plug in our 372. And then our number of observations is the total number of people who sat on the grand jury, which is our 884. So once we have that, we can set up our hypotheses to be the same as our problem. So our null hypothesis is our p-value, or our probability being equal to 0.786. And our alternative hypothesis would be if it's less than 78.6%. So once we have this set up, just like we had the first part of our equation, we can hit compute. And that's how we can calculate our test statistic and our p-value. So you'll also notice that they give us a p-value that's so small, they just tell us that it's less than 0.00001. So we can enter our p-value as 0 if you would like, or you can put in 0.001, depending on how many decimal places it wants. Both should be acceptable, but just in case, I wanted to make sure I noted it. So the last step, we're going to compare our p-value to our alpha. So our p-value was basically 0, and our alpha, they tell us, is 0.01. So our alpha is bigger than our p-value, so we're going to reject our null hypothesis. And very clearly, if our p-value is 0, it seems that the jury selection process is unfair towards that certain ethnicity. And that should conclude number 7.